So let's step back and think a little bit more formally about this, this notion of a probability function. What is a probability function? And sort of what properties does it have? Well, the probability function of x, where x is a discrete random variable, is defined as the function such that for any x, f sub x of little x is equal to the probability that x is equal to little x. Okay? So this is just formalizing what we did in the last two examples. We just created these functions. We called them little f, called them probability functions, and denoted them little f, I guess. And all we did is we just computed probabilities that our random variable was equal to various values, and that defined our probability function. Okay? So what are some of the properties that the probability function is going to have? Well, because it defines the probability with which random variables take on various values, it is by its nature going to have certain properties that it always satisfies. So in particular, the value of the probability function for any x is going to be between 0 and 1. Okay? And that's just by definition, it's a probability. Okay? And you can go back and, we can go back and check the examples I did. All of the probabilities I computed were between 0 and 1. The second property is that if you sum up over all of the possible values that the random variable can take on, then if you sum up the probability function, then that sum has to equal 1. Okay? Again, this follows directly from the fact that the probability function is sort of describing probabilities. So let me just go back and we can just sort of convince ourselves. I did double check, so it is in fact true. But we can convince ourselves those things do sum to 1. And in the other example, those also sum to 1. Okay? And the third thing that's very useful to know about a probability function is how to use it to compute probabilities. Okay? So obviously, if you just want the probability of a particular value of x, the probability function gives it to you. You just read it off. But what if you want the probability of a whole set of different values of x? Well, not surprisingly, you just sum up the probability function over x's in that set. Okay? And so that's going to be useful when we're given a probability function for a random variable and we want to calculate the probability of that x is in a particular set or region or something like that. Okay? So I briefly mentioned continuous random variables a couple minutes ago. So for continuous random variables, we're rarely going to start with a verbal description of some kind of experiment like we did with the discrete random variables. And instead, we're typically just given a function that describes sort of the probabilities with which the probabilities with which a continuous random variable is in various regions. Okay? And that function is called a density. So all of you have seen lots of examples of densities. Over on the left is a normal density. This is a triangular density. These are examples of log beta densities. So you've all seen examples of them, and we will sort of see many additional examples and sort of learn how to manipulate them in various ways. But let me say a little bit more about this function, the density, or also known as the probability density function. Okay? So it's an analog in a lot of ways to the discrete probability function that we were just discussing. And the next slide will talk about how they're similar and different. But first, let me give you sort of a more formal definition of what a PDF or probability density function or density is. Okay? Well, so in fact, we define the continuous random variables in terms of this function. So let me just do that. A random variable x is continuous if there exists a non-negative function, f sub x, such that for any interval a in the real line, the probability that x is an a is just equal to the integral over that region a of the PDF, f sub x. Okay? So note that I've given these two functions, the one that I said was analogous for the discrete random variable and the continuous random variable. They have different terms. One's called a probability function, one's called a probability density function. Okay? And we do that to emphasize the fact that they're not exactly the same, they don't behave exactly the same way mathematically. However, they're going to be, they're analogous in a lot of ways, and they're going to be used in a lot of the same ways. And so that's why we use the same notation, this sort of f sub x of little x notation. Okay? So we use the same notation for both the sort of discrete probability function and the continuous probability density function. Okay? Oh, and yes, that's the PDF, the F.